You went to a job affair? Really? That's huh? Oh. Who has an answer? Oh, yeah. Let's wait for 1 more minute. All right. Now, as we're waiting, so I don't know if it's good news, bad news. So I'll be making a second test. See, listen to her. Well, we'll see. Hey, Anna, all right. So the second test that covers 5 to 5A, right? That's coming up maybe before the spring break, like in like 2 weeks or something. So this morning, right? Professor D said that I need to make the second test. But you, well, I don't think they'll let me do that. You know what? You know, if it was a midterm, now the thing is, I don't think there will be a midterm. You know, if we have a second test, then the midterm will be too close to the test. If it's a midterm, that I think that the norm is we can make all multiple choices. So I mean, most likely there will be still FRQs. The reason why I said that, it might be a good news if you think that since I'm going to be one who make the test, so that and as we're getting closer to the test, whatever I said, I mean it. You have to understand, right? And those tricks and skills, I'm going to tell you to make sure that you will, do well in the test. But I still have to make sure that it's ethical. I'm not, making just my students to do well in my tests, right? It needs to be fair. So the version, I'll try to create, as soon as possible. I'll send it to everyone in the group. The master instructor is going to review it. They will provide some feedback, right? And also, the thing is, even if you guys will be able to use the scientific calculator, but still, our concern is, people need to learn things in the proper way. And the reason why we don't want to use the calculator in our test is, sometimes questions, might be as simple as just take a number, put it into calculator. So now, as far as I understand, you will be able to use the scientific calculator, but the kind of questions we pick will be the kind of question that you might not find the scientific calculator that useful. Just in case, because you can still use, the thing is not that useful. It's not going to be completely useless, right? I mean, we'll hope that we'll be able to find questions that even with the calculator, there's nothing you can do about. I know, yeah, it sounds weird if I say it. No, the thing is, it's probably useless because you have very limited amount of time. You can think through the process and figure it out, the right way to use the calculator, it will still be helpful. Anyway, I don't know yet, but I'll try to get the first draft ready as soon as possible to make sure that it passes Professor D, all the other instructors, right? So then I can say for sure, hey, there will be 20 questions, 25 or 15, so I can let you know, right? Things like that. So we'll see about the level of questions I will end up picking. Anyway, now, yeah, who has an answer? Okay, I'm pick 4, pick 3. You have to go with the flow, they might be wrong. But you know what? I'm glad that you guys are looking at C and D, right? And then, of course, I think that it's better that we realize right before the test, well, not right before the test, while we're practicing, that, oh, I tend to pick this one because I thought that's going one way, but it's actually going the other way, since the phase shift is to the left, right? So I sense that it might be the reason why. Anyway, so I still want to do it in a standard way, so that, people will be able to refer to the notes or my work or even the recording. So the best way to deal with secant and cosecant function in the graphs is to think about their reference functions, right? So instead of plotting the secant, let me plot -2 cosine x plus pi over 4. Oh yeah, thank you. Oops. All right. So please make sure that you're very quick recalling what the cosine function, sine function, even tangent, cotangent look like. The cosine will be something like this, right? This is the regular cosine function without any shift or stretch or reflection. Right, it goes from -1 to 1, and up here is 2 pi. And if you put -2 pi there, right, just make it symmetric. So now let's say we'll do the phase shift later, right? Let's first get the the vertical stretch, right, and the flip. So I need to make the graph like twice as tall, right, and then flip upside down. So instead of going between -1 and 1, I'll make it go between -2 and 2. And instead of starting from the positive, I'll start from the bottom. So it will be something like this. Right? So this is -2 cosine x. Do you guys agree? Right? Okay. So now we're gonna take up the phase shift. So I'm gonna shift this graph to the left, right? By pi over 4. But how big is pi over 4? So you can use the scale on the original graph. So let's say if this is pi, half it will be pi over 2, right? And take another half, like a quarter, right? That will be pi over 4. So we'll be shifting the graph to the left just by a little bit. But to make it, easy to tell, so let me just grab it. So let's say instead of plotting a new one, which could very likely get messy, so I'll just, if you don't mind, let me just drag this graph to make it shift. All right, well, that's good enough. Now, do you see that the center minimum was at the y-axis, right? And I was shifting it a little bit to the left by like a little portion there, right? It's about like pi over 4, right? But that's cosine. So now you need to get the reciprocal of it. And that's actually the fun part of graphing, the reciprocal function. But let me first put down a few VAs. VA, I mean the vertical asymptotes, right? So based off this cosine graph, can you guys tell me where the VA is going to be for the secant? Good. Can you tell us, Joel, why does it have to be at the x-intercepts? Like here, 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 here. In some sense, yes. Do you remember? Okay, well, at least you remember, the x-intercepts, right? So now, at the x-intercepts, how much the cosine is equal to? The cosine graph is 0, right? So those are the 0 value of the cosine, but secant is 1 over cosine. If cosine is going to be 0 at those x-intercepts, secant is going to be 1 over 0, which is undefined, right? But I told you last time that it's better to understand it as going to positive infinity or negative infinity. And that's exactly what you want from the function when it gets close to the VA, right? Therefore, we'll put the VAs at those x-intercepts of the cosine function, and that will make sure that when we draw the secant, it's not going to go too wide. So now, to get the secant graph, all we have to do is go to every single peak in the trough, find the maximal or the minimal, right? Let's say you're going to have a U shape down from the cosine, right? But hold that, hold on to, the maximum, just flip it up and make it like a U shape going up. And the curve's going to go straight up, not straight up, going up to the infinity as it's getting closer to the VA, right? Let me use, different color, right? So go to the maximal, right? Flip it up to get a U shape, right? The same thing here, right? Same thing there. There you go, right? So of course, you don't have to do that because that's like, you seriously get what the graph looks like and you go ahead and compare. But I'm sure that you guys all see that. I mean, A and B are just wrong because, you see that the maximum minimum are not even correct, right? I want it to be -2 and 2. But you notice that the reason why it's shifting to that way and opening down at this point is because this is what the cosine look like, and you're flipping it down, right? It has to be a downward U, right, at this point. Anyway, so the answer is letter C, right? So please make sure that you understand it and find a way to get the answer like that within a minute or two. Okay. All right. So now we need to move on to the inverse trig, right, which is 5.7. But before I do that, so I want to make sure that you guys still remember back in our college algebra what a inverse function is really trying to tell us, all right? Or how do we understand, maybe in your own words, what an inverse function is? Okay. Now, can anyone share your thoughts? Like, if you have to tell me in a few words, like, what do you think will be an inverse function? How do you understand it in your own way? There's nothing right or wrong at this point. It's just that it's a mathematical term. Yeah, Alani? Good. Like a swapping the input output at opposite. Yeah. So I mean, you know what? That's probably good enough. If you have that kind of a understanding. So now let's make it a bit more explicit. So we have a function x squared. What do you think will be the inverse of it? Square root of x, right? So you guys okay with the notation f inverse, right? To the negative power. That is not reciprocal, okay? And it's not any kind of an algebraic, operation. It's just a notation or the new function, and we named it after the f. Let's understand better what inverse function is designed to. So why don't you think about this? I think that we probably did that back in college algebra. Would you be able to figure out how much this whole thing is? Like, I'm trying to evaluate the function f at 2. Then I'll take whatever you get from f of 2, feed it to the f inverse, and get whatever the f inverse is going to tell me. What do you think it's going to be equal to? Well, let's try this. How much is f of 2? 4, right? 2 squared, right? So you're going to take the 4, right? Put the 4 here, and you ask the inverse to do what? Square root of 4, which is going to be 2, right? Well, you know what? You can try 3. F inverse of f of 3 is 3, okay? Is that a coincidence? To get back to the same number? No, because again, that's what the inverse try to do. So inverse is like so think about what might be one of the most commonly used as computer shortcut. I said, you guys probably like Control C, Control V, right? But what about Control Z? You guys use that a lot, especially editing? No? Well, I use that a lot. When I type up things, I always type it around and I Control Z, right? Whatever I did, sometimes, when I do something crazy, to the files, right? I accidentally deleted something. I don't even know what I deleted. Like Control Z, it come back, right? So it undo whatever you have done. And guess what? This is what the inverse function trying to do. Why do you think that you're getting the 4 out of the 2? Because you feed it to the function f, and it's going to do something magical to it, right? And not that magical, just square it, right? So you feed it to the function with the 2, it returns the 4, right? But the inverse will take that 4 and put it back. Completely undo it, as if that nothing has happened to the 2. Because function is trying to change the input and give it the output. Feed it to something, it spits out a number, right? And the inverse is going to do the opposite. Okay. So now, let's think about a sine function. The sine function tries to tell us if you're looking at an angle, let's say 30 degrees, right? You can draw a right triangle and figure it out the ratio opposite of the hypotenuse. And we start to memorize, or the calculator is going to have everything stored in a calculator. So sine 30 is 1/2. If you know, right? Or draw the triangle. Well, you know what? Let's put it over here. Let's say this is, let's say 30, right? That's 1, that's 2, that's radical 3. So sine 30 is 1/2. But so far, we're so used to, we have so many trig functions. All we have to do is just feed it with an angle, right? And it returns, some ratio or some numbers. But do you ever wonder, what if you don't know the angle, but you happen to know the ratio? You want to know what angle it is. So you might sometimes want to know at what angle sine of it will be 1/2. But it's going to be 30, right? But what if it's not a special angle? I want to know, okay, at what angle sine is going to return 1/3, right? Things like that. And that's why we need the inverse trig. But let's see how we can define it. Starting from the sine function. So this is the graph of the sine function. And like I said last time, if you have the graph of a function, you know everything about it. And that's why we just observe the function and think about a way to invert it. So hopefully, if you feed it to a number, it's going to return an angle. But there's an issue with the graph. If you draw a horizontal line, it intersects the graph at more than one point. And this line is actually, at 1/2, right? You see that it intersects at a point here, which is pi over 6, which is, 30 degrees, right? And this is 5 pi over 6. And also there are so many other points, right? There are infinite many of those points. They're all going to return 1/2, right? Sine pi over 6 1/2, sine 5 pi over 6 1/2, sine of 13 pi over 6 is 1/2. But do you realize this function doesn't pass the horizontal line test? Does it ring a bell? Horizontal line test? It tells you that, hey, this function is a fine function, but it does not have an inverse. But why is that? Like I said, inverse will take the output of a function and return the corresponding input of that function. If the inverse sign is supposed to tell us at what angle you're going to get 1/2. You know sine 30 is 1/2, but at what angle sine of that angle must be 1/2. But see what happens. The function might tell us multiple angles. So this is not what we want from the function. So basically, you're trying to do this in a calculator, right? So you look for a function button. Let's go with the basic. So you say, I have a function. Let's say, well, I wish I have. Anyone has a calculator I can use? Maybe just the basic one. Anyone? Oh yeah, that one is. So let me do the square, right? That's a function button, right? So I type in a 3. Thank you. 3, right? And I hit this button square that tells me 9, right? If you do it for 1,000,000 times, it's going to return 9 for 1,000,000 times. But if you do that with the sine inverse, if you allow multiple angles, multiple inputs for the same output, you're going to ask, hey, what is the angle, right? That's going to give me 1/2. It will tell you it might be pi over 6. So you try it again, it say, it might be 5 pi over 6. Well, then now the calculator is meaningless, right? So it doesn't tell you a unique output anymore because we allowed multiple angles corresponding to the same, output in the first place. So that's why we want to, truncate a graph or only look at part of the graph of the sine function so that the graph will be 1-to-1 and the relation between the angle and the number will be 1-to-1. So whatever I provide the inverse sign, a number is going to return a unique angle. And what mathematicians decided to do is they decided to only focus on the center piece of the sine graph. I'm going to draw 2 reference lines. They're not VAs, by the way, just 2 vertical lines. And I want you to forget about the graph that's to the left of the first vertical line, and also forget about the graph to the right of the second vertical line. Only looking at this piece from the trough to the peak there, it's only half of a wave, right? Which is only pi units y. And you know what's nice about that? It's monotonic. That means it's increasing. It's 1-to-1. That means whenever you pick an angle, say pi over 6, you're only going to get 1/2. If you say what angle within this restricted region will get me -1, and the sine's going to take -pi over 2, and that's the only angle will return -1 through the sine. But you know that if you do allow the remaining part of the graph, there will be infinite many points or angles going to return -1. So now we're eliminating all those ambiguity. We want 1-to-1 correspondence. An angle corresponding to that definite number. Okay. But how do we write an inverse function? If I know what it's supposed to do, right? How do I, let's say in a computer or coding language, right, need to call that function, right? What do we call it? The mathematician invented a new function notation, and they call it sine inverse. So that's not sine to the -1 power, even though it looks like that, and there's a reason why they use the inverse power, but it reads sine inverse. Okay. Now, here's the logic flow. We start out the regular sine function, and we limit or we restrict the domain by looking at not all real numbers anymore. For the x, I only take from -pi over 2 to pi over 2. And this is called the restricted domain, because on the restricted domain, the sign is invertible. Otherwise, it's parametric. And since we want to get the x given a y, right? Because we want the angle now, right? And that's what we want to find from the inverse sign. So mathematician says that why don't we just do it by putting the x on the left, right, y on the right. That's the input now, right? Let's say 1/2. So you hope that it's going to tell you 30 degrees. You put sine inverse, right? And typically we use parentheses to enclose the input, right? So yeah, that's as easy as it is. Just define a new function, and it does what it's supposed to do. The magical, inverse, right, of the sine. But here's the confusing part, right? And you can read the remaining, as you're thinking about my question. So my question for you is, what is the domain of this inverse function? What is the domain of this inverse function? If that's not that obvious, let me say, what about the range of this inverse function? By the way, domain is just all possible inputs, right? Range is all possible outputs. What we did is we take y equal to sine x. So x is going to be an input for the sine, y is the output. We flip them because the inverse sign is going to return the x, right? The angle, if you tell them what the y is supposed to be. So now what do you think? If we're only looking at the restricted domain of the sine, what will be the range of inverse sine? Is this x the same as the x over there? Yes, because we flipped them, right? So instead of putting an x on the right, we'll put it on the left. So the range of the inverse sine function is negative pi over 2 to pi over 2. Because that's the only part of the domain we picked to invert the sine. Therefore, the restricted domain of the sine becomes the range of the inverse sine. But what about the domain of the inverse sine? Should the domain of the inverse sine be just the what of the original sine function? The range of the original sine function, right? And the range of the original function is, you guys remember, the range of the sine is -1 to 1. Therefore, the domain of the inverse sine is -1 to 1. So now, this is why people get confused. If they're thinking about domain and range of a sine, domain of a sine is all real numbers. Range is -1 to 1. To go into inverse sine, the domain of the inverse sine is -1 to 1. The range of inverse sine is not all real numbers, from negative pi over 2 to pi over 2. Okay. And you say, why do you have to know that? There are a lot of questions that you can only work it out if you know the domain and range of functions and their inverse. Somehow that mathematician decided to do something. They thought that they were doing us a favor, but they actually made things worse. They say, guys, have you ever seen a function that takes the y as the input? Because it's just odd that you have the y on the right-hand side, right? They say, you know what? Let's just rename them. Instead of calling it x on the left, let's call it y. So now, as you can see that here, you can trust that the x here will be the same x here. That's why if you limit x to be only between negative pi over 2 to pi over 2, that was the restricted domain, and it becomes the range of the inverse sine. But here, if you see the x, it's not the same x over there anymore, right? I mean, it's what it is, right? So sometimes I think that it is the notation, convention, even the definition that confuse us in the first place. And unfortunately, that's the case for the inverse trig. Okay. Now, next time, remember that on Monday, right? I said that we'll have some special guests, Miss Cameron. Right? So not that I say that just because she's gonna come, then I'll do a Kahoot, but I will do a Kahoot to see, right, if you guys can quickly tell what is the domain of the inverse sine, right? What is the range of the regular sine, right? So I'll scrounge them. Say it again. Well, it's in a textbook, right? So now the thing is, I think I use the same example in the fall semester. You guys know the alphabet song, right? And you don't have to sing it. You can think about from A to Z, right? It can be very quickly, then just finish it. Reading letters within a couple seconds. But if all of a sudden I ask you to, recite from Z to A, so you might say, well, that's hard because you've never done that. But seriously, it's not really that hard. You just have to make sure that you get it right and be fast. That is hard because you're probably not going to be able to do it only after you're trying it for a few times. And the thinking was, say I want to start from Z, but I know that it's XYZ. That's what I'm used to, right? So I'll go ZYX. So then what's next? UVW, WVU, right? And I'll keep going backwards. After I try it for a few times, I'll be able to do it, right? Well, of course, there's no point of doing it, unless you want to just show, in a family get together just because you can, right? But the thing is, inverse sines is like that. So because we're so used to the sine that takes an angle and spits out the number. But now I want you to think about there's another function that takes the number and put out, the angle. And you actually swap the x and y, you swap the domain of range, right? It's just a little catch here. The domain of the regular sine is all real numbers. I showed you that the graph that extends to positive and negative infinity, but it's not invertible. So I have to restrict the domain to only negative pi over 2 to the pi over 2, right? And I flip the x and y, so the restricted domain of the sine becomes the range of the inverse sine. So the process, the logic is straightforward. You just go back and forth, right? But it's not that intuitive since you have to go backwards and you have to make it quick. And the only secret, to make it quick is, you try it for a few times and, just feel natural, right? All right, now let's take a look at a question in a test or at the test level to see, if you guys can figure it out. Even at this point, I didn't even tell you too much about, how to work these out, but just by definition of inverse sine, can you guys figure it out? Number 29. Do not use calculator. So sine inverse of radical 3 over 2. Think about what it means. You're feeding radical 3 over 2 to the sine inverse. What are you trying to get? The options are all, looks like they're all angles, right? But they're in radians. So let me do you a favor. I'll write this in a better way. So basically, you're trying to find an angle, right, by feeding radical 3 over 2 to sine inverse. But not many people like the inverse. But what if I flip it back? Don't you think it simply means that if you evaluate the sine at angle theta, it should return radical 3 over 2? Does it make sense? The regular sine takes the angle theta, right, and gets you somehow radical 3 over 2. But now, instead of asking, I know the angle, right? How much is sine of that angle? I want to know if I know the value of the sine has to be radical 3 over 2, what kind of angle will do that? What do you think? Can you think about an angle? Sine of it will be radical 3 over 2. And that has to be a special angle. You know, I'm not asking you to remember some say 60, right? So because sine 30 is 1/2, right? And again, you know, if you can draw the right triangle, right? That's 30. So this is 1, that's 2, radical 3, right? That's 60. So yes, sine 60 is radical 3 over 2. Therefore, the angle theta must be 60 degrees, or in radians, it better be pi over 3, right? I said we happen to realize, you know, that ratio, radical 3 over 2, is the ratio of a special angle, right? And it turns out sine 60 happen to be radical 3 over 2. Then we go back and say, oh, we know the angle has to be 60, right? And it had to be, you know, pi over 3 radians, right? So now, you guys have a calculator, right? Do that in a calculator. Help me to type in exactly sine inverse of radical 3 over 2. You all need to get either 60 degree, right, or pi over 3 radians. But be careful with the function button. You're gonna find the sine button, right? And normally you're gonna go second, and the sine button, right? It's gonna put in the sine inverse. But if you're on decimals, then I think that you can, you know, just put in the sine inverse right away. Yeah. But please be aware of that, what modes you're in. So you might be in degree mode, radian mode, right? But I want radians. But if you know you get 60 degrees, then you're fine, right? But you have to figure it out how to go into the radian mode and back and forth. Yes.
For future tests, we will have access to a sine tensor calculator.
Yes. Yes.
Okay.
Yeah.
Thank you.
Yeah, exactly. You know, and tell me what you get. If you get 60, you're good because you're in degree mode, right? If you get, well, some fancy calculator is going to show pi over 3 as is, right? Which is good. Unless you get maybe 1.0 something, right? So that's going to be in radians as well because, you know, pi is 3.14. 3.14 divided by 1, divided by 3 is about 1 point something. All right, does it work? Yeah, so that's the kind of a, you know, syntax things you have to figure out from your own calculator. So just now, Max asked me to confirm if you guys do have access to the scientific calculator in our future tests. The answer is yes. But I don't think that I'll be allowed to pick those kind of questions in the second test. Right? I wish I could, right? But you know why? Because it's as simple as you just type the thing in the calculator and you get the answer, right? So there will be some questions you can still use the calculator, but not going to be as useful as those questions. So just be aware of, okay? But you have to know how to type it up, right? Now, let's see the weird part of, again, the inverse trig. Okay, so I'm going to show you again this page so you know that how the trig and the inverse trig, you know, in this case, the sine and inverse sine are related, right? So let's test if it's going to do that magical thing, right? So I know that for this function and its inverse, if you feed it to a number, let the function affect it, then later have the inverse function act on it, you get the same number back, right? So you guys go ahead and type it up in a calculator for me. Do sine inverse of sine of 2 radians, not 2 degrees, 2 radians. Right? And tell me what you get. Type exactly what you see here. Sine inverse and sine of 2 radians. Yes. Let me see.
Oh, wait. I put pi instead of.
No, it's sine inverse on the outside.
Oh.
Did you get 2? You do? You sure you get the sine inverse on the outside? Right. And it's not 2. That's the problem. All right. So now here's the right way, because on that calculator, well, let me see. Did you put sine inverse on the outside? Are you in degree or radians? You're in degree.
Yeah.
You need to be in radians. Yeah. So, well, you guys have to figure it out. Because I don't know about that calculator. I wish I know how to go into the radian. All right. So it is not 2. I think that if you do it right, it will be 1.14, something like that, right? And the problem is, it's supposed to give us something like a 2, right? When it turns out that, hey, this is not a random number. It's actually pi minus 2. All right, so, and you do get that 2 from that 2. That means it is kind of trying to do it, but it didn't quite get you the things you thought, right? And that's why I said that some of the questions might be confusing. So you start to realize that maybe you cannot trust the calculator, because in this case, calculator is right, you're wrong, right? You thought it's gonna be 2, right? But there'll be some question that calculator might be wrong. You might be right if you understand it, right? So that's why we try to make the calculator as not as helpful as it's supposed to be, so that you actually do have to know how it works out. Yeah, I see some hands up. Yeah.
Was another number, you can just and I get 2 as the answer. I could just do pi minus 2, pi minus the number I get.
Yes, but the problem is, how do you know there has to be pi minus 2, right? So that's why we have to figure it out when you realize the restrict domain and how important it is to use it. So we're not there yet, but I'm letting you know that there'll be questions like that. It will be confusing. Now, so we already know that the sine function, right, has to be restricted. So then you're only getting the centerpiece, right? That's what it looks like if you do get rid of the graph to the left or right of these 2 special points. And now can you see that this graph of the inverse sine is also symmetric, right? Just like every inverse function is supposed to. So if I put them together, and they're kind of nice, that the red curve is the sine, right? The blue curve is the cosine, the inverse sine. They are reflected or symmetric about that famous line y equals x, right? That's a general property for any function that's inverse, okay? So now that's it. Well, we do have quite a few minutes left over. So I'm not going to seriously go into the inverse cosine, but I do want to try to answer the same question, kind of question when it comes to domain and range with the inverse cosine, because all you need to do is understand what part of the graph, the cosine, do we pick to invert it. Okay, so let me show you. All right, so that's the cosine graph, right? So do you see that? Now I cannot take the same restricted domain anymore. We wish that we can be consistent, but no, it doesn't work. If you only pick this part, see that it doesn't pass the horizontal line test, right? So now we have no choice but to pick either this part to the right of the y-axis or to the left of the y-axis. So, I mean, they're not really that much different. So some people like this, part to the right, up to the left, because, the graph is rising. But unfortunately, you have to deal with negative angles. So mathematicians decided to go with the part that's to the right of the y-axis. So now for the purpose of inverting the cosine, we go with the restricted domain of the cosine, which is 0 to pi. Okay. But what about the range? The range of the cosine is still from -1 to 1, even if you restrict the domain. It's just that you cannot go with all real numbers anymore. Just like the sine, right? You go from -pi/2 to pi/2. For cosine, you go from 0 to pi, right? That's the restricted domain. So now, here's the question. If I write y equal to cosine inverse of x, listen carefully. What is the domain of inverse cosine? You're gonna get a Kahoot quiz like that. I don't even mind to tell you this is the exactly the question because I want to see who's gonna be quick enough to figure out the right answer. What is the domain of the inverse cosine? Look at the graph. What part of the graph the cosine did we pick to invert it? So now the domain of the inverse cosine must be, that's the domain of the cosine. The domain of the inverse cosine is the range of the cosine, which is from -1 to 1, right? What about the range of inverse cosine? The range of the inverse cosine is the restricted domain of the cosine, which was picked as 0 to pi. All right. But you saw that weird question. Sine inverse of a sine 2 is not 2, it's pi/2, pi minus 2. That question can be solved if you know the restricted domain, you know how it's work out, plus some other techniques. But you have to know what the restricted domain is. Okay. All right. So now again, let's try something real quick. Before you go. Try 30. Cosine inverse. Just take a guess, because I think that all you need to know is the cosine is going to be taking the angle and spits out this, radical 2/2. But now, what if you go back, right? At what angle you think that the cosine will spit out -2, radical 2/2? 1 radians? Oh, 8. Okay. Yeah. Yeah. Pi/4, right? 45 degree, right? You see that it could be as easy as that without a calculator, because you can only get those questions about special angles, right? But with the calculator, so that becomes trivial. It's good to tease your mind with the inverse, right, of sine and cosine. But to be honest, that they won't be on a test. Okay, it will not be on a test.
Yes, one, we're just gonna remove.
Wait, say it again.
You're just gonna remove the easiest question.
Not because I'm gonna be reviewing. If I pick them, they will be removed by the rest of the instructors. Right? Yeah.